Welcome fellow learners. In the last video, we have seen how we can integrate Gradio with our SQL database chain. We have seen how we can easily create a UI which can be interactable, where we can input our questions in the natural language text format, and then it will pass to the language model, fetch the results from it, and provide us the result in the text format again. So that it will create a chatbot where we can interact with it. It also remembers the previous context from the data such that in the further question, it can remember the past history also. So apart from that, in this video, we will create a kind of talk with data UI where we can record our audio, pass to a speech to text model that will convert it into text. Then that text will be passed to the language model, which will generate the output. And the generated text output will again be converted into the speech format. So for that part, we are going to import two additional things. One is speech to text model, another one is text to speech model. For the speech to text part, we are going to use Facebook HF Seamless M40 media model. So this model is available in this Hugging Face space. You can get this model from here. Its size is around 5 GB. If you see 4.84 GB, you can get this model from here. The importing code is already written in this. If you go in the down section of this page, here it is written. I have used the same code. For that part, we need to import three things. One is from the transformer library, auto processor and seamless M40 model. Auto processor will basically process the audio that we will record. Seamless M40 model, it is the basically speech to text model, which will convert speech to text. Torch audio is basically used to load the audio that we have recorded, so that it can be converted into the waveform and provided into the next part where we will generate text from the speech. So these three things we need to import for this model. I have already imported over here. It takes a few seconds to load it. After that, I have created a function which will convert the speech into the text format. So for that part, once the audio is recorded, it will be saved in a file path. I will show it in the further section of this video, how it is being saved into the file or recorded audio. Once we get that file path, first we will use the torch audio to load the audio, and then we will use our processor. So torch audio, first it will sample the waveform, its frequency rate and all, and then we will use this same auto processor from transformer to process this audio such that it can be readable. It can be converted into readable format for the model, this seamless M40 model. Once we use the processor, we will again use the model. We will finally use the model's generate function. It will take input from this processor and further give the output tokens. And then once we got the output tokens, we will decode this output tokens into the text format. So this is the final text that we will get from this seamless M40 model. Now we have imported text to speech model. We have also created this function speech to text, which takes audio file as an input and convert that audio file into the text format. The next thing is we want to convert text into the speech format. So for that part, we are going to use STTS. You can import this library using pip. We are going to use this STTS from command line. For running command line is in Python, you can import subprocess. We will use this subprocess library to run this STTS to command. So it will basically take this text as an input and then convert it into the audio format. So I have created a file which will be output.wav. So this will be our text to speech function. Also, like I have appended some arguments such that it can convert the audio subtitles to a file also, which will be like any file you can write over here. I have written a name like hello.vtt. So this is the text to speech function. So now our both additional models are being shown here, speech to text and text to speech. The further part is same. These two functions, create chain and extraction, we have seen in the last video. This create chain basically creates a SQL database chain which takes user's input question, which will be in natural language format, and produce the language model generated text output. And the next this extract data function is basically implemented over here to keep track of previous context from the user and generated answer from the language model. Also, it takes it keeps last three chat history of the user and append it to the user's input question, and then pass it to the language model so that it can remember the past history of the chat, so that it can give the better answer to the user. Finally, we are going to use Gradio. So for Gradio part, it's mostly same. The one thing is the two things basically. We are going to use two another audio, you can say, boxes over here. So I will run this cell and show you how our UI will look like. So this box is same chat with data. This is the same chatbot box. This new box is output audio box, where you will see the audio output from the model. So another box you can see is this record box, where you will record your audio. So now for that part, we are using these two other gr.audio basically a line over in this code. This gr.audio basically is for the output part, which will automatically play the output text written over here using the STTS that we have seen earlier. And the another one is this gr.audio, which will basically takes the audio input from the microphone and convert it into a file path. So this way our audio file will be generated once it is being recorded. So if you see, this is the same function that we have used in the last video. Once the user enters a question and basically asks for the language model to generate it, it will pass it to this function. It takes this over here. Now one other thing you will see over here this time is file path. So if you see, this file path is basically for the audio file path. Now instead of only text message as input, we are also going to have this audio file path over here. So this audio file path will be used whenever user doesn't ask question in text format. It will take audio input. It will convert that audio input from speech to text. It will use the same speech to text function from this over here. Convert that into speech to text. It will get the user's generated message, and then finally user's question that user has asked from in the speech audio format, and then finally pass it to the same extract data function, which will call the language model and generate the output from the language model. So this is a little different from the previous implementation that we have seen for the Gradio. Another thing you will notice is this submit button in the UI. So in the last video, we were only using the text chat text as an input. So whenever user write a question over here, it will basically, we can directly enter it and it will submit. For this part, we have also implemented this record box over here. So for this, once we record the audio, we need to press this submit button so that it can pass it to the backend and then generate text using this speech to text. And the further process is same. After that, once the language model generated the text data, now we need to convert the text into the speech to text format. For that part, we have used this speech to text that I have shown you earlier, this STTS library. So this will convert into text to speech format. As the output is in this output audio variable, so this will be auto-played as I have given it a parameter. So let's see how this works. So as I have already told you, we are using the same training data set that we have seen in the previous videos also. So we will going to record our audio and ask the question. So I'll first ask a simple question like how many passengers were there. So I'll record this using this record from microphone button. How many passengers were there? We can also listen to it. How does it record it? How many passengers were there? So it's okay. Now we will press this submit button and fetch the results from it. So first it will convert speech to text using the seamless M40 model from Facebook.
There were a total of 891 passengers in the passenger data table.
So now you have listened to it. So it's like first it converted from speech to text, then language model came into picture. That text is being passed to the language model. Same SQL database chain ran. It generated the text output from this, and then that text output again converted from speech to text using the HTTS. So it looks quite fascinating, and it also looks like we are chatting with the data. So it looks quite good. It looks fascinating that we can talk with the data, we can get output from it. So now I think it completes all the parts that we have seen in the first introduction video of this Langchain implementation. So now let's recap what we have learned and achieved throughout this tutorial series. First, we began with the Titanic dataset and converted that data into an SQLite database, making it more accessible and easier to query for our AI models. Next, we introduced the SQL Database Chain, which basically allows us to directly chat with our Titanic data. So we can ask the questions to it, receive answers from it, and it looks like data itself could speak. So that was quite fascinating. Then we gone deeper into it and saw a few problems with it. So that's why we have created some custom prompts so that this refinement process improved our quality of interaction with that SQL database chain. So it was really good working with that custom prompts so that we can get better answers from the SQL database chain. Afterwards, we done more and gone more deeper into the mechanics of the Langchain. How does this each component of this SQL database chain works? So for that part, we have used different runnable sequences and pass-throughs to find out the inner working of this SQL database chain. We have seen the create SQL query chain, then fetching the data from the database, and then finally using a language model to generate the output from this database output and the SQL query and the user's input question. Then we finally used GradeU, an open source library, with which we have created a chat with data UI. This was really good to showcase a simple UI in a fast way to anyone, such that they can chat with the data. Finally, we pushed our boundaries by interacting with the UI, such that we can record our audio, convert that audio into text using the speech to text, and then generating the text output from the language model, and finally converting the text into speech again, so that it looks like we are talking with the data. So as we conclude our series, it's important to reflect on the impact of our work. We have not only learned to harness the power of Langchains and LLMs, but also explored innovative ways to make data interactive and engaging. Throughout our journey, we have seen how technology can transform static information into dynamic. We have created conversational UI also. So this was really extraordinary and working on this for the first time. So while our series may be ending, the journey of discovery is just beginning. I encourage you to take these concepts further, experiment with the new dataset, and explore the endless possibilities that Langchain and AI offers. So thanks for making till the last video of the series. Goodbye until the next time.